Okay, so this section is going to be talking about section 2.2. Sorry, this recording is going to be talking about section 2.2, which is basically all about various kinds of graphs. So we're going to go over, I'm mostly going to give examples of the types of graphs. This is another section where we're going to have a lot of vocabulary to get through. So we're going to start off with pie charts. Right? You've probably seen one of those before, right? You generally have a circle, and it's going to be divided up into various size pieces. And this is actually generally a graphical way to represent the relative frequency tables that we were talking about last section. So right, because the idea is that the bigger piece of pie is associated with a particular thing, the larger the proportion or the relative size of that class. So in this case, we'd see that there's roughly twice, maybe? I don't know. I didn't draw it very well to scale. But there's a lot more stuff in the squiggly parts than there is in these straight line parts. And so it's sort of an idea to get a glance of what proportions of the whole a particular category has. So whenever you want to make a pie chart, the first thing you're going to do is find the relative frequency, and then you're going to divide a circle up using those proportions. So another one that you've probably seen is a bar graph, right? And so that's one that looks like this. Right, and so this one is good for just representing the regular old frequency. Right, because all this is telling you is how many there are of a certain thing. Right, so with a chart, the count, however many there are always these things over here on the right, and these are going to be your classes again. So the categories that you're splitting things up into. And it doesn't so much tell you about that relative frequency, that proportion. It just tells you about how many are in any given thing. It's a nice way to compare and say there's more of something, significantly amount more, without worrying about the proportions that go into it. And so this is really, pretty much this is the purest representation of a frequency distribution, is this bar graph. There's a couple of different types of this. So a Pareto chart is one where it's a bar graph, but specifically it's those bar graphs that descend, right? So this right here, not Pareto, because it doesn't go tallest, second tallest, third tallest, fourth tallest, so on and so forth. And now if we recall back to, what section was that? Let me look at my cheat sheet. Section 1.2, Pareto chart is good for nominal data, right? So if we recall from section 1.2, nominal data is information that is labels or names or something, but it doesn't have a particular order, right? So, for example, you wouldn't want to say, like, this is the number of B's, and then the number of C's, and then the number of A's, D's, and F's. This is bad chart design, right? Because if you're looking at letter grades, right, you expect it to go A, B, C, D, F, right? That's sort of the way it should go. But when you reorder everything to make it go from biggest to smallest, you leave that sort of natural ordering for the information down here on the bottom. So this is a Pareto chart, but it was a bad choice for a Pareto chart, right? So generally, if you want to do a Pareto chart, it needs to be nominal data, so data that doesn't have any particular order set with it, right? So names, hair color, eye color, things like that are best for Pareto charts, and then you can see at a glance who has the most, who has the second most, so on and so forth. So it orders them by their frequency rather than what actually makes sense. So that's one thing. Another type of bar graph is a side-by-side graph. And really on the same line, I'm going to do a stacked bar graph. Let's see here. Because both of these are for when you have two different samples of data that you want to display somehow together. Right, so all these that we talked about before, they're from one sample with multiple different classes that sample fits into. Side-by-side bar graph and stacked bar graph are for when you have two different samples and you want to compare them. So side-by-side, you might have something like this. I'm going to bring some color into it. Right, so we have our black sample and our purple sample. And we put them sort of side by side, so we compare and say, okay, whatever this was measuring, whatever class this is, so there are 3 classes here and 2 samples. So whatever that first class is, sample 2 had more of it than sample 1 did. Right, whatever the second class is, sample 1 had more of it than sample 2. And same for this third graph. Now, if we wanted to do a stacked bar graph, then what we would do is we would take this sample 1, and then on top of it, we'd put sample 2. And I'm drawing some very bad graphs here because I'm not great at drawing rectangles while talking. But so with a stacked bar graph, as we can see, we stack the 2 samples on top of one another. Right, so here we might care more about the classes. So this is comparing samples within classes, And this one is comparing classes using both samples. So this tells us how many of any given class we have when we put those two samples in the same place. Right? So there's different things you could learn from it, and it all depends what you want to know. And the last type, so one thing I didn't mention for that is that all of this stuff is for qualitative data. Right, so these are when we have classes that are words, labels, names, things along those lines, not for when we have numerical data. For numerical data, we have histograms. And so the difference with histograms, I'm going to try to draw this a little better because it's a graphical thing that's the main difference. Right, so this looks a lot like a bar graph, but the difference is that we don't have these gaps. Right? And so specifically here, right, it makes sense for there to be a gap between B and C, like we have here, because those are different. They're separated. They have nothing to do with one another. Right here, if we were talking about this might be from our last one. Let's say this is 25, this is 37, this is 49, this is 61, this is 73. Right, if we were using the classes from the first example we did in last section, though not the frequencies because I've forgotten what they are at this point, the numbers push right up on one another, right? We really want to include everything between 25 and 73. We don't want to leave any numbers out. So the main difference between a histogram, which is what you use for quantitative data, and a bar graph, which is what you use for qualitative data, is that histograms, bars touch each other on the sides. And in a bar graph, if you had a category where there was nobody there, you might just leave it off. In a histogram, if we have a category where nothing's there, then we leave space for it. So those are both histograms. And so one of the things that from what we have last time is that rather than being labeled like I did here, this one might be labeled by its midpoint. So if I can recall what that was, something like that. I don't know. I'm having problems remembering, but we're gonna go with it. There we go. Right, so this is one of the ways that there we go. I skipped ahead of myself a little bit. That you might label on a histogram, and that's one of the things that the midpoint that we talked about last time can really come in handy for, is labeling that. Instead of making it a little bit busy like this, we just have this sort of midpoint to give the average in some sense of things in that group. It's not really the average, but it's sort of a measure of center, which we'll talk more about later. So another thing that we do with numeric data is a stem and leaf diagram. And that one's kind of a weird one that I'm going to do with an example, right? So if I have this as a set of data, right? Well, one way I can do that is making a stem and leaf plot, which is another 2-column table. And the stem is usually the sort of the top, the front of a number, and leaf is the bottom or the back of a number. There can be some variations, and you'll often want a key, but I'll include that later. So if I look at all the first digits here, we've got some numbers with the first digit 1. We've got a 17, so we've got that. We've got an 18, we've got that, and we've got a 19 and a 19, so we've got that. Right, and then we have some with the first digit of 2. We've got a second digit of 2, second digit of 6, and a second digit of 7, and then 3. We've got 2 second digits of 1, second digit of 2, 4 and 5 just have their one thing each. Right, so that's a stem and leaf plot. And then if we're good and upfront with things, we want to go ahead and put a key which says that 1/7 equals 17. Right, that's pretty obvious with what we have here and what we started with, but it can get more complicated. Say if we would have an entirely different set if the key was that right, the 1 stood for the thousands place and the 7 stood for the hundreds place, right? That would be a very different data set. But it would be a perfectly viable stem and leaf plot for that very different data set, right? Let's see. So another one that you see frequently, the last one that we have here, is a line graph. And that's one where instead of having these classes, right, maybe we were doing a longitudinal study, right, which if we recall means that we were going over a considerable period of time, right, and we had data sets that cross time like this. So this isn't counting how many times something happened, but we want to know the general trends of, was it going up, was it going down, was it fluctuating a lot like this one did. So it's not only for longitudinal studies, but it's one of the really good ways to represent longitudinal studies. Is using this sort of line graph thing. And so that's a collection of all the different graphs types in this section, right? We've got some that are better for qualitative. We've got some that are better for quantitative. Some that sort of skirt the line. But within it, as long as you're using the right one for the right type of data, right? You don't want to use a histogram for qualitative and you don't really want to use a Pareto graph unless it's nominal data. And side by side and stacked are really only good if you have 2 samples. But with those few specifications, right, it really becomes a matter of recognizing which ones are going to work best for your data set, right, and making decisions based on what you're trying to say and what answers you're trying to get at, and what you're trying to communicate, basically, right? These graphs are just a different way to communicate, and as with most communication, getting used to it comes with practice, right? So hopefully we'll get some of that with your homeworks, and we'll talk a little bit more about graphs and how they work next time. So I will see y'all then.